Hello, and today we are going to be talking about balancing equations. So the very first thing that you need to do whenever you're given an equation that you need to balance is you need to identify how many of each species you have on both the reactant side and the product side, because you want the number to be the same on the left and on the right, because remember, conservation of matter, we don't create things, we don't destroy things. So what we start with and what we end up with might be rearranged, but you're going to have the same amount. So we're going to use red for reactants. So let's go over to our left. We have iron, and on our left-hand side we have one iron. We have hydrogen, and we have two of those. And we have sulfur, and we have one of those. And we have oxygen, and we have four of those. Now remember, when we have subscripts like this, what that means is that for every one molecule of sulfuric acid, so every molecule of sulfuric acid, you're going to have two atoms of hydrogen. These subscripts tell me how many atoms of each element are in a single molecule. Remember that. So now let's go over to the product side, and we're going to use purple for products. So we have iron once again, of course. So if we have iron, we have two of those guys. We're going to keep it going in the same order. So since I have hydrogen here, I want to put hydrogen here so that I can just glance at it and know what's what. So we have hydrogen, and I have two of those. We have sulfur, and just like in math, when you see that parentheses, that means that that number 3 is distributed. This means that you have 3 actual sulfate blobs. Okay, so if you have 3 sulfate blobs, that means you're going to have 3 sulfurs, and you're going to have 3 times 4 oxygens, because each sulfate that you have has 4 oxygens. Each sulfate that you have has 1 sulfur. So you'll wind up with, for your sulfurs, you'll have 3. Remember to distribute that subscript. And for oxygen, 3 times 4, you have 12. Okay? So now I'm going to keep using different colors as we go through this so that you can keep track and know how each coefficient that we add changes what you have. So coming over here, we know that we have two iron over here, and we have one over here. And now one thing that you always want to remember is always start with something other than hydrogen and other than oxygen. Hydrogen and oxygen are really common in our reactants and our products. So a lot of times you'll see that if you change them, they're going to just keep changing and keep changing and keep changing. Whereas your core molecules, you're something that's not hydrogen, not oxygen. That's going to, once you balance it, it's going to tend to stay balanced. So you want to start with anything except your hydrogens and oxygens. So let's start with our iron. So if it's 2 over here, the easiest thing you can do is come over here. You've got 1 iron all by itself. You change that, nothing else changes. So we're going to go ahead and put a 2 right in front of that guy. What that does, that changes this to a 2. Okay? So now I have 2 irons. Irons are balanced, but I still am not balanced for anything else. The next glaring discrepancy that I see is my sulfurs. So I've got 3 here and 1 here. Easiest way to fix that, multiply this one times 3. So we're going to put a 3 up here. Now that means that I have 3 sulfurs, but this 3 also gets multiplied times each subscript. So I have 3 times 2, that means I have 6 hydrogens here. And I have 3 times 4, which means I have 12 oxygens. Now, if we look at our equation, or if we look at our numbers, we have 2 irons on both sides, they're balanced. We have 3 sulfurs on both sides, they're balanced. We have 12 oxygens on both sides, they're balanced. The only thing left that's not balanced is our hydrogen. So now in order to fix our hydrogen, if we go over here, we'll notice that whatever it is has to be multiplied by 2, because this is a diatomic molecule. So we want to get it to 6. Lowest common factor of 3 and 2 is 6. So 2, we are going to multiply this guy by 3. That gives us 6 hydrogens and changes nothing else. So now if you look down here on our species chart, you see that everything balances out. So another example that we can do is we can do one where we have a situation where our oxygens and hydrogens don't balance quite so easy. So what we're going to look at is we are going to look at C2H6 plus O2 makes CO2 plus H2O. Okay? Pretty much nothing but carbons, oxygens, hydrogen in here. Simple combustion reaction. Okay? So first things first, again, going back to red for reactants, we're going to start by identifying our reactants. So on the left we have carbon. We have 2 carbons. We have hydrogen, of course, and we have 6 of those. And we have oxygen, and we have 2 of those. So, coming over purple for products, looking at this, we have carbon, and we have 1 of those. We have, keeping it even, so we're going to put hydrogens next. We have 2. Now here's where it gets a little tricky. We have oxygen in both our carbon dioxide and in our water. So this plus sign, we're going to add together how many oxygens we have here and how many we have here. So we have 2 oxygens here and 1 here, so we have a total of 3 oxygens. Alrighty. So again, remember, never ever start by balancing your oxygens or hydrogens. Always start with whatever else you have. Doesn't matter what it is, as long as it's not hydrogen or oxygen. So starting with our carbon, we see that we have 2 here. Alright, well I've got 1 over here, easy peasy lemon squeezy. All we have to do is multiply that times 2, right? So let's put a 2 here. That means that we now have 2 carbons, but this also affected how many oxygens we have. So we now have 2 times 2, that's 4, plus our 1 from over here. So now we have 5 oxygens total. Okay? So we've run out of things that aren't carbon, or I'm sorry, that aren't oxygen and hydrogen. Now we have to start messing around with our oxygens and hydrogens. So let's start with our hydrogens. We have 6 here. We have 2 here. Lowest common factor of 2 and 3 is 6. Or, yes, lowest common factor is 6. So if you've got 2, you multiply by 3. If you've got 3, you multiply by 2. Okay? So we're going to put a 3 smack dab in front of that. What that means is that now we have 6 hydrogens, which is great because now the hydrogens are balanced, but we've now messed with our oxygens again. So now we have 3 times 1 is 3, plus 2 times 2 is 4. So we have 4 plus 3, we have 7 oxygens total. Now at this point you might be going, oh my gosh, 7 is a prime number. How on earth am I going to multiply anything times it and somehow, or multiply something times something and come out with 7? Here's the way that you can do it without tearing your hair out, okay? When you have something that's diatomic, like oxygen, a lot of times this happens with oxygen because oxygen likes to make lots of friends and form lots of different molecules. So when you have oxygen that's diatomic, okay, you know that whatever you multiply it times, you're going to get twice that, okay? So if you want to get 7 oxygens on the reactant side, you need to have 3.5 of this guy, right? 7 halves, okay? You divide it by 2, you get 7, all right? 7 halves. Now, we cannot have a fraction as our coefficient, but here's the trick. Let's just, for kicks, put our 7 halves here, okay? Now, we know we can't have that as a fraction as our coefficient. So what we do to the left, we do to the right. We want to get rid of what's underneath it. If we multiply everything times 2, you're going to find that you come out with just the 7 as your coefficient there. So we'll multiply everything times 2. Now we have 7 is our coefficient here. 2 is our coefficient there. What we do to the left, we do to the right. So I now have 4 instead of 2 here. And I now have 3 times 2 is 6 here. So what we're going to do is we're going to fix all of our numbers. So now I have, instead of 2 carbons, I have 4. Instead of 6 hydrogens, I have 12. If I look over here at my oxygens, now I have 14. So 7 times 2 is 14. Coming over here, I have 4 carbons. 4 times, as far as hydrogens go, I have 6 times 2, so I have 12 hydrogens. I now have 4 times 2 is 8 plus 6, so 8 plus 6 is 14. So now if I look at everything, I have 4 carbons on both sides, I have 12 hydrogens on both sides, and I have 14 oxygens on both sides. Am I balanced? Yes. So this can get a lot more complicated, obviously. And when you have things where you've got a sulfate here, phosphate there, it can really get confusing, especially when you have your subscripts. So always make sure, break it down into your species. If you don't break it down into the species, you're going to find that you lose track of things. If it helps you to use different colored pens to keep track of what you do as you go through it, just like I did here, where my coefficients and the color that I used to cross off and correct my numbers were the same, that may be a key that helps you understand where things go. In any case, I hope that this helped you, and keep your eyes peeled for more videos.